Let ABCD be a rectangle inscribed in a circle of radius 13 centimeter. Which one of the following pairs can represent in centimeter the possible length and breadth of ABCD? Okay, so the situation we have is like this. We have a circle inside which a rectangle is inscribed, and the rectangle is ABCD. So let's quickly label the rectangle. Let's say this is A, B, C and D. The circle is of radius 13 centimeter. So we know the diameter of the circle is going to be double of that, and the diameter is also going to be the diagonal for our rectangle. So let's draw the diagonal here. This is going to be 26 centimeter, double of 13 centimeter. Okay. Which one of the following pairs can represent the length of the rectangle and the breadth of the rectangle, that is AD and AB? What do I understand about the relationship between what is given and what is being asked? So AD, AB, now these two are sides of this right angle triangle, because all the internal angles of a rectangle, they're all going to be equal to 90 degrees. So this is going to be 90 degrees. So AD and AB are sides of a right angle triangle where the hypotenuse is equal to 26. So at this stage, you should be able to recollect Pythagorean triplets, where the hypotenuse is a factor of 26. So the one that comes to my mind is 5, 12, 13, as 13 is a factor of 26. Now this is a primitive Pythagorean triplet. Now what do you mean by primitive Pythagorean triplet? It's a triplet where the numbers are co-primes to each other. Means you don't have a common factor for the three numbers. Now you can take any Pythagorean triplet and multiply each one of the values by a constant. The resulting three numbers that you're going to get, they're also going to be Pythagorean triplets. So let's do that. Let's multiply each one of them by 2, because I am targeting 26 as the hypotenuse. So 13 into 2 will give me 26. So let's multiply each one of them by 2. So 5 into 2, 12 into 2, 13 into 2. We're going to get 10, 24 and 26. Now this is a possibility. So when 26 is the diagonal, there is a possibility that the length and breadth could be 24 and 10 respectively. Now let's see whether that is there in the options. Luckily, we have that in the options, so that's the answer for this question. Now, this question could have been solved within 10 to 15 seconds in the exam, provided you know the values of the Pythagorean triplets. Now, let's look at some of those Pythagorean triplets that you should know before you can go into the exam, so that you can have an edge during the exam. So these are certain triplets you should know by heart to have some kind of an edge in the exam. Starting with the smallest, 3, 4, 5. 5, 12, 13, 7, 24, 25, 9, 40, 41, 11, 60, 61. These are the ones that you should definitely know, where the smallest of the triplets is an odd number. The smallest of the triplets being an even number, we have 8, 15, 17, 12, 35, 37, 20, 21 and 29. These are the values that you should definitely know by heart. And even among these values, the ones that do come more frequently are these 3 and these 2. So whenever you see, for instance, let's say you're looking at 48 and 50 being the two sides where 50 is the hypotenuse of a right angle triangle, even without going for the Pythagoras theorem, you should be able to identify that, hey, 48, 50 is actually double of 24 and 25. So this one has to be double of 7. So this one has to be 14. So that's the kind of edge you will get if you know all these values by heart.